Practice problem number 4, the last practice problem before you'll be moving on to Khan Academy today, asks you to again graph a system of linear equations and then use that graph, a second part, to identify any common solution. The challenge here may be that for the second equation, x plus 2y equals 15, it's not in slope-intercept form. So to graph that equation will be a bit more challenging. We do not know the slope and the y-intercept just by looking at this equation, because it is not solved for y. It's not in slope-intercept form. So we'll talk about how to graph equations like that. Take a look at these two equations on full screen on the whiteboard. First one, y equals 2x. That is solved for y. It's in slope-intercept form. I know if x is 0, then y has to equal 0. There's nothing over there. This is a proportional relationship like we talked about before. It's going to pass through the origin or have a y-intercept of 0. The slope is positive 2, so our slope, which we'll put a little bit lower, our slope means every time x increases by 1, the y value is going to gain 2 units. So rise over run, a slope of 2 over 1. This is a pretty easy equation to graph at this point if you've been working on them. The more challenging one, the purple equation, is not in slope-intercept form, so we don't know the slope and y-intercept at the beginning. In this case, I would rather just substitute, pick a couple easy values for x to plug into the equation to solve for y. I recognize something important. This was an odd number, and I have 2y. So I want x to be some kind of odd number just so y ends up being an integer. Otherwise, if I just make x 0, y is going to have to be 7.5 anytime x is an even number. That's going to give us decimals. So you could have picked any values for x, plugged them in, and then solved for y to make solutions that you could graph. I happen to pick odd ones just as I recognize that would make my life a bit easier. If I make x into 1, if x became a positive 1, then I know y would have to be 7, because 1 plus 14 makes 15, and 2 times 7 would give us 14. If I make x into 5 instead for this equation, if I substitute a 5 in for x into that equation, then I need this 2y term to equal 10. I'm going to subtract 5 from both sides if needed, but I think you all see 10 plus 5 would give us 15. That means y has to be 5, because 2 times 5 would give us 10. So that's how I quickly found 2 solutions to this equation. I know it's a linear equation when I recognize there's no exponents. X and y just have coefficients, and there's some constant number. This is a linear equation. 2 solutions is all I need to graph it. So we'll graph the purple one first. It's going to go through 2 points. One of them has to be x is 1, y will be 7, and if x is 5, y has to have the value of 5. Those are the 2 points. Those 2 points are the ones we'll plot for the purple equation. So for purple, we know when x has a value of 1, y has to have a value of positive 7. And we also know that when x has a value of 5, y has to have a value of positive 5 as well. For the orange equation, I know it's going to pass through the origin as proportional relationship, or it's a y-intercept of 0. And each time x increases by 1, y is going to rise or gain 2 units of value. So go ahead, up by 2 every time x gains 1 unit. At this point, we can go ahead and plot our 2 lines. They're going to run through each one of these. So we'll quickly plot that orange line that has to run through all 3 of these points. And then the purple line, we know it'll be a straight line passing to the 2 solutions we found previously. We can see now our common solution as well. We'll go ahead and place a final point there. It's on the purple line, it's on the orange line at the same time. We know if x is 3 and y is 6, that will be a solution to both the purple and orange equation at the same time. So now that we've created our graph, we're able to see again our common solution where the lines intersect. A solution to both equations would be if x is 3, y is 6. You could plug this ordered pair into both of these equations, and you'll see it works in both of these equations.